Hello, I'm Natalia, and I'm a PhD student in the University of Valladolid, and I'm going to talk about part of my work that is, in this case, long-term evolution of pine and oak forests across the municipalities of the Bosque Modelo Palencia. We see that there is an information gap between the forest information that we have at the national level to the local level. So we have modern forest management demands informed decision making at local level, but the information is disaggregated in different databases and disconnected, and also they have different formats. So it's difficult to use this information and different levels that they are made to do it for making decisions on this local level. So we have, for example, at the national level that the government publishes this information for free. National Forest Inventory, different edition of this, National Forest Maps, and also administrative boundaries. So we use all this information to analyze the forest in the Bosque Modelo Palencia as a case study. Since this area is candidate to become the first model forest in Spain, because promotes local participation in forest management and conservation, and it covers 91 municipalities with a total of 4,000 square kilometers. And of this area, 28% is forest area, and of this 28%, 24% is pine and oak forest. And most of these pine and oak forests are public forests. And the area of pine is 44,000 hectares, and for the oak forest is 33, almost 34,000 hectares. So the main objective of our work is to integrate all this information, just from the inventory, the forest maps, and also for the municipal boundaries, into decision support systems using link open data, geographical information systems, and also interactive dashboards to see all this information in one glance, and facilitate the use of this to local management. So we have the first problem here is we have the last three forest inventories editions have information at the tree level, like height, diameter, basal area, and also at the plot level, aggregated this information per hectare with volume, basal area, density per trees, per species, and also by stratum per province. In this case, Palencia has 14 stratum classes that are classified based on the main species and also the cover of these species in the strata. But we don't have data in between the plot data and the stratum, like the municipality. And we can do this aggregation of just focusing on the plots information of the National Forest Inventory, because we don't have, in many cases, in the municipalities, a lot of plots to do this. So we use more information, like the forest maps, to use the strata of the province to analyze and calculate the trees per hectare, the basal area per hectare, and the volume per hectare, to do stratified overage. And using the different edition of the inventory that we have, almost 30 years of evolution of the trees, to see this stock information at the municipality level over the years. So we integrate all this information with other databases that are public in a dashboard, which provides a strategic perspective for territorial planning and summarize different information. We have this an example of a municipality of Velilla del Río Carrión, in this Bosque Modelo Palencia that we designed divided in different areas, like municipality context, when you have the location of the municipality, the county, see there is protected areas, and there is public forest. And also we have the forest characteristics and the stock's evolution during the 3 inventories, and also the quality and damage of the trees and the ecosystem services that we have in this municipality. This is the same example of the Velilla del Río Carrión dashboard, and we have the different parts bigger. So in the first part, we see the location, the county is Guardo, and it has 35 public forests larger than 100 hectares. And also more of the half of the municipality is within the Montaña Palentina Natural Park. So we can see all of this in this part. In the other parts of forest stocks, we can see the evolution of the trees per hectare, also the basal area per hectare, and the volume of the 3 main species that in this case are Pinus sylvestris, Quercus petraea, Quercus pyrenaica. And we can see that during the 3 inventories, the species are progressive increase in the both variables that we measure, and also that the main species is Pinus sylvestris, with a lot of difference of the other 2. And also we can calculate the carbon storage, and we can see that the evolution of the carbon storage during this inventory is increasing in the 3rd one and in the 4th one. We also have the information of the tree quality of the 3 inventories and the 3 damage, and we can see that the tree quality increased during the inventories. Then in the 2nd inventory, the tree quality, it was very poor of the trees. Almost half of the trees are standing dead or disease or have diseases trees. And the tree damage is the decrease in the 3rd inventory, but increase a little bit in the 4th one. And most of the damage are because of biotic factors and wind. And also we have another part, the forest characteristics, when we can see the number of plots in the inventory of each edition that they measure in the municipality, and the number of plots and trees that are in the same edition in the 3 editions of the inventory, and we can compare it. And we can see also the evolution of the surface of each species in the municipality. And we can see decrease in Pinus sylvestris and Quercus pyrenaica from one map to another. And also we can see this, the ecosystem services and evaluation of the estimate value of all of this. And conclusion, the integration of multiple databases has transformed and scattered information into useful knowledge for local forest management. Dashboards enable clear visualization in one page, allowing navigation across temporal scales like the inventories and forest maps. All data and graphs of this work are published in GitHub. And future work, we want to expand this dashboard to a national level, not just in the Bosque Modelo Palencia through a web application like Forest Explorer, and increase data integration with other data like climate and other databases that are published, and conduct user testing with stakeholders to see the necessity of these people to use it to the municipalities or other spatial level, to know how they want to use this information and if we want to improve it. Thank you.